All right, welcome to College Algebra, section 7.1. We are going to be solving systems of equations in three variables. You may have done this before, but we are going to do it in a way that's going to help us get ready for the next concept, which is matrices. And so you might see this done a little bit different than ways you've done it before. I'm going to start out with what's familiar to you, and then I will go into the way that they kind of want us to do it so we get used to what matrices are doing with our equations. So we're going to be able to solve equations in three variables. The method that they use is called left to right elimination. Some systems do not have an independent solution, so we'll look at dependent systems and determine when a system is inconsistent. We'll talk about what that means when we get there. First of all, this is what a system of three equations with three unknowns looks like. So we need to solve this. Now, when I teach this in like Algebra 1, probably not 1 with three variables, Algebra 2, I just take a look at all the x's, all the y's, and all the z's, and I pick one that looks the easiest to get the same coefficient in front of. So in this problem, they wouldn't be super hard. X has 2 and 3, so I probably wouldn't choose that. Y has 3, -3, -1, and 1, so that's pretty easy to multiply those and I'll get them the same. And z is also easy, so I'm just going to choose z. It doesn't really matter. You can pick y or even x. Not a big deal. So what I want to do here is I'm going to multiply all of these in pairs of 2. I'm going to take 2 at a time, and I'm going to eliminate z. So if I'm eliminating z with this pair, I would multiply this first equation by -2. So I'm going to rewrite the first equation times -2, every single term, times -2. And make sure you don't mess up on your multiplying, and even multiply this end number on the other side. Otherwise, you will have a problem, and that's going to mess everything up later. So second equation, I'm just going to write it down. And then we're going to eliminate by adding straight down. So I just add here. That's -3x plus 5y. The z's eliminate, equals -1. And then I'm going to take these two equations and eliminate z again. The trick is you have to use the same letter both times. You can't eliminate z here and then x here, because then you won't have equations for the next step. All right, if I'm going to eliminate z here, I'm going to multiply the second equation, or third equation, by +2 so that these have opposite coefficients. So the first equation I'm not changing. I'm just going to write that down. And the second equation, I'm multiplying everything by 2. And we're going to add that straight down. So we get 7x plus y equals 15. Okay, so the whole point of that was we eliminated z. So now we can take these two equations and eliminate another variable. So we have the choice of x. So we have a -3 and a 7. Or we have the choice of y. We have a 5 and a 1. So I'm going to choose y, eliminate y, by multiplying this equation by -5. So I'm going to take the left-hand equation and the right one over here. I'm going to multiply this by -5, which is 75 negative. Make sure you multiply by a negative. So negative, 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 everything's negative. Okay, now when I add these, I get -38x. Those eliminate, equals -76. And 38 times 2 is 76, so x equals 2. Okay, now that's not my final answer, because my final answer needs to have an x and a y and a z. So basically from here, you just work your way back to plugging things back in. So then now that I have x equals 2, I will go back a step and plug in x equals 2. Into an equation that only has an x and a y. If you go all the way to the top, then you're going to have two unknowns again. So you only want to go up one step where you know what x is and you don't know what y is. So 7 times 2 plus y equals 15. Well, 7 times 2 is 14. So y equals 1. And then now that I know x and y, I can go all the way up to the very top and any of those three equations. So I'm just going to go with the first one because it's the first one I see. So if I plug in a 2 for x and a 1 for y, plus z equals -1. That's 4 minus 3. That's 1. And I subtract 1, I get -2. This is off the screen, but z equals -2 is my third answer. So the answer is x is 2, y is 1, and z is -2. Sometimes you'll see it like this. Sometimes you will have them just with equals. All right, so that is using a method called elimination, and we actually had to do elimination 1, 2, 3 different times in order to solve this problem. And that's how this is traditionally taught. So now I'm going to show you how to use the method that this book wants you to kind of just try to figure out a little bit, because this is one way to solve matrices, which we're going to come up later. So first of all, there's a couple rules, and the rules are very logical. So like when I'm solving this equation that we were just doing, it doesn't really matter which equation was on top, which one was first, which one was second, which one was third. No, they're 3 separate equations. So I can change their order anytime I want, and that's just number 1 here. You can interchange them if you want, if you think that that might make it easier. You can multiply both sides of an equation by the same non-zero number. Well, we did that. We had to multiply an equation by -2. We had to multiply both sides to keep it equivalent. And then we can also multiply an equation by a number and add it to a second equation and replace the second equation with that sum. And basically what it means is that when I do this multiplication, I can then add it to another equation and replace one equation. So I'm replacing these with equivalent equations and combining them to make new equations. So here are the steps when necessary interchange. The very first step, you want x to have a coefficient of 1. So the first equation needs a 1 in the top left corner. Then we're going to use these other rules to do what it wants. So our goal basically is to get a 1 in the first. This is not a good color. Let me change my. Get a 1x and then zeros. Zero here and here. And then it doesn't matter what y and what z and what number we have, okay? And then our next goal after we get the zeros here is to get a 1y here. And then the third time we're going to get a 1z. So this is kind of the pattern that you're going to follow. And you'll see what I mean when I try. So let's start, and I'll explain as we go. The steps are written out here, but I'm also going to kind of show you. So the very first step is I want a 1 in this top left spot, and that is not a 1. I have a few options. I could divide everything by 2, but then I would get some fractions, so I don't really like that choice. Another option is I can just swap equations. So that's all they did right here, is they just switched equation 1 and equation 2. All right, and then, so my step 1 is good. Now I'm happy. I have a 1 here. My next step is to get zeros here. And here, actually, get 0 here. Okay, if I can get that to go away, then I'm going to be one step closer. So how do I make that go away? This is the step that takes a little bit to get used to. You can take a whole equation, multiply it by whatever you want, and add it to this equation. So if I want this to 0 out, I'm going to multiply this by -2 and add it to that. So let's start. 1 times -2 plus 2 is 0. Now we're going to do the move over. You have to do the entire equation. If you're going to do one term, you got to do them all. So this one is -1 times -2 is 2. Positive 2y minus 3y is -y. And for the z, that would be -4z plus z is -3z. We have to do the number part too. This would be 6 plus -1 is 5. So I'm taking the first equation, times -2 and adding it to the second equation. And then instead of writing the second equation, I'm replacing it with what I got there. So if you didn't understand that, we're going to do that a lot more times because we have to do it to the third equation. All right, notice my first equation hasn't changed. This equation is this equation, not changed. This one we multiplied by -2, added it to equation 2, and replaced it and put the answer here. Okay, now we're going to do the third equation, and I want to make this a 0, so I'm going to multiply by -3. So if I do 1 times -3 plus 3, I get 0x. If I do -3 times -y is 3y plus y, I get 4y. This is -6 plus -1 is -7. And 9 plus 9 is 18. So that is step 1. I got a 1 in the x spot, and my other two x terms are 0. All right, now we're going to move on to the next goal. The next goal is to get a 1 in the place where there is a y. So right here, this is my next focus. I want this to be a positive 1, and it's a -1. This is an equation. I can do whatever I want, so I'm just going to multiply this entire equation by -1 and switch the signs. So that's what we're doing on the next page. Multiply by -1. All right, so you'll see that that has been done right here. These are now positive, positive, negative. So I have my 1, 0, 0, and I have a 1y. So my next goal then is going to be to make this a 0. So I'm going to take equation 2, and I'm going to multiply it by -4 and add it to equation 3. So if I put a -4 here, plus 4, I will get 0. So the 0y, it went away. 3 times -4 is -12z, plus -7z is -19z, and 20 plus 18 is 38. So that step got me there. Notice the first and second equation did not change. They just got rewritten. All right, we're almost done. I promise. Super close. Okay, last step. Well, not quite last. Almost last step is all I have left is this, and there's only one variable. So if there's only one variable left, all I need to do is solve for z. So divide that by -19, and you get z equals 2. Now we have part of our solution. We know z equals -2. So if I'm trying to find x, y, z, I have 1/3 of my answer. But it's just like before. Now that I have z is -2, I can work my way back up. The good news is your way back up is with you. It's right here in this set of equations. So I just have to go up one little equation here, right here, and plug in a 2. So I'm going to do that on the next page because it's written out for you. Oh, it's actually just kind of written out for you. So we're going to put that -2 into this equation right here. So we get y plus 3 times -2 equals -5. That is -6. Sorry, y plus -6 equals -5. So we add 6 to both sides and we get 1. So now we know y is 1, z is -2, and we can go back to this first equation knowing that y is 1 and z is -2. Okay, and then solve that. So we have x minus 1 plus -4, so that's -5 equals -3. Add 5 both sides, and we get 2. So now we have all 3 parts of our solution. I know that seemed like a lot more than you need to do, but it really does help you understand how to solve a matrix if you understand what you're doing here with equations. So there are some more examples in here, and I'm going to go through them probably a little bit faster, but they are in the context of applications, so I'll help get the equation set up, and then the work is shown on this, so you can follow along as you wish. So let's get started. A manufacturer of furniture has 3 models of chairs: the Anderson, the Blake, and the Colonial. The number of hours required for framing, upholstering, and finishing for each chair is given. So this is tons of information. They didn't write it all out. They just made us a table to organize it. The company has 1,500 hours a week for framing. So I'm going to put total is 1,500. 2,100 hours for upholstery and 850 hours for finishing. So this is like how much time on their machine they have available or how many workers do those skills. So we're limited. We can't just make a whole bunch of one thing because it might take up too much framing time or whatever. We want to balance out what we have the time available for and the products that we're making and the number of chairs. So how would we set up an equation for this? Well, my variables are going to be the three different kinds. So conveniently, I'm going to call them A, B, and C, and how long it takes to do each. So this is almost an equation for you. 2A plus 3B plus 1C equals 1,500. Like it's ready to go. So I'm going to turn the page, and that's already set up. What they did is rearranged it, because if I did it in the same order, then what did I have on top? I had a 2A on top, and I definitely want to have a 1 on top. So I can pick one of these other equations to flip up to the top. So that's all they did right here. They did them in a different order. They put the finish, they basically flipped it over. The finishing is on top, or bottom now, because that's where the, oh no, 2 is. Now they're going to flip it. There we go. So they just moved the upholstery up is what they did. All right, so basically they're starting to solve here. We have a 1, my pen is not writing, in this first location here. So that's what we want. Now we want to get a 0 here. So how are we going to get this zeroed out? What do you think? We're going to multiply this equation by -2 and add it to that equation. So one term at a time. This one plus that one will be 0. This one, -4 plus 3 is -1. So there's going to be a -y. I'll turn the page because it's there. And then if you do the, it's going to be flipping back and forth. This one's -6 plus 1, so that's -5. And then you can use your calculator to multiply -2,100 times, -2 times 2,100 plus 1,500, and you get -2,700. All right, so we got a 0 here. They also did the next one, which is if I do -2 times this, -1. -1 this time. So in order to do the third equation, I'm going to multiply by -1. So -1 plus 1 is 0. -2 plus 2 is 0. And this one's -3 plus 0.5. And this one, I'll let you use your calculator. -1 times 2,100 plus 850. But the good news is on that one, it eliminated the x and the y. So we actually can just jump to the z. Can you tell me what z equals right now? All you have to do is divide that, and we get 500. So notice how fast that was. It really wasn't that much more work. It was convenient because it came out to the double 0 here. But there would have only been like 2 more steps anyway. So it can go fast sometimes. All right, now that I know that z is 500, I would plug that back into this second equation. If you had divided everything by negative, that's fine because that's following the rules. So you don't have to deal with these negatives if you don't want to. You can solve it that way. Anyway, y equals 200, and then you can plug in the z and the y into that first equation to find out that x is 200. So in order to utilize all of their materials and all of their framing, upholstery, and finishing time, they would need to make this quantity of each kind of chair. So this is basically to help a company maximize their productivity. All right, sometimes when you solve a system of equations, you do not get a unique solution. Usually we get X, Y, Z. We get 3 answers. That is one independent, unique answer. Okay, but sometimes, like with 2 lines, you could have a pair of parallel lines and they never cross. And that would be an example of inconsistent. So sometimes it's taught as no solution. The reason we call it inconsistent now is because I might have 3 lines. And so if these 2 are parallel, they're definitely not, but there still is a point in common. So it's, yeah, anyway, There's a different name for it, but there is no solution. You can still write no solution. I'm not too picky about that. But you also need to know the word is inconsistent. Also, what can happen is you can end up with the same line. You graph one line, you graph the second line, and it happens to be the same. And then the third line comes in, and who knows where it is. It even could be the same line. That's dependent because there are infinite number of solutions. Infinite solutions, or in algebra, we said all real numbers sometimes. When you're solving an equation, it's not necessarily all real numbers, so that's not a great answer, but there are an infinite number of solutions. It's just not every single point is a solution. All right, what does this look like in an equation? So here's an example. When we look at it, you can kind of glance and tell that these first and third equations kind of look a lot alike. So what happens when we start our process? Well, we have a 1, so we're good there. We have a 0 here, so we're good there. So let's make this a 0. In order to do that, all I need to do is add these two equations. So if I add these two equations, I get 0, 0, 0, and 15. And so what happens to my third equation is I end up with just 0 equals 15, and there's no letters left. If all the letters go away, then it's one of these weird things. It's either inconsistent or it's dependent. All right, so this one, because it is no solution, it is inconsistent because 0 does not equal 15, and that is not a true statement. If it was the other kind, the dependent ones, this would be a true statement. Most of the time you'll end up with 0 equals 0, but sometimes you could get like 15 equals 15 because that's also true. Here's another one. You can't always tell by glancing. They don't look like they're exactly the same or anything, but maybe. So let's just start them out. First of all, I want to get a 1 in this spot. I could swap these equations. I think what they did this time is just multiplied equation 1 by -1. This notation right here, they're telling you what they did. So they just took that first equation times -1 and rewrote it. And now we're going to try to get a 0 here. So if we get a 0 here, we want to take equation 1 times -1 and add it to equation 2. So -1 plus this is 0. -1 times this is 1 plus 2 is 3. 3 plus 1 is 3. And 0 plus 6 is 6. So that gives me that equation. And then if I want to get a 0 here, I would multiply it instead by 2. So we're going to multiply this equation by 2, add it to that. We get 0. 2 times -1 plus -1 is -3. -2 times 2 is -4 plus 1 is -3. 0, -6. All right, now look at these two guys. Now I've started the process of solving, getting 1, 0, 0. But now when I see this, I'm just going to take a look there. Those two equations are the same equation. So how do you finish this problem? This is a little bit new maybe. You kind of have to keep going. So let's keep going, and our next step then would be to get a 0 here. So a 1. Get a 1 here. So we're going to do that by dividing by 3. Just divide this whole thing by 3 and rewrite. And we get this one. That was my divide by 3 step. You could also divide this one by 3. It really wouldn't matter. But we're going to just keep going with the process. I want to get a 0 here. So I'm going to multiply this equation by 3 and add it to this equation. So 3 times this is 0. 3 times this plus this is 0. 3 times this plus this is 0. So I ended up with a 0 equals 0 equation. All right. So I knew a few steps ago that this was going to be one of these dependent, infinitely many solution kind of problems. However, I kept going. And the reason that I kept going is because I have to actually write more than that. You can't just say infinitely many solutions and be done. You're actually going to say what those infinite solutions are. This is what it looks like. Pretty much, if you follow this process, you're always going to just let z be z. Z is any number you want. How are the other answers related to that? Because they have to be all solutions still. They can't just pick 1, 2, 3 and that's the answer. I have to actually see how they're related. So if I know that z is a number that I'm going to pick, how would I find y? Well, I can just take this equation and solve it for z. Z equals, oh, sorry, I meant to solve it for y. Subtract z from both sides. So y equals 2 minus z. Well, that's going to be my y then, 2 minus z. Whatever z was, I'm going to take 2 minus it. Then for x, since I know y is 2 minus z, I'm going to plug that in. So this is going to be x minus 2 minus z minus 2z equals 0. And solve this equation for x. Get x alone. Well, let's distribute the negative first. Minus 2 plus z minus 2z. So that's x minus 2 minus z. So I'm going to add those over to the other side. Z plus 2, or 2 plus z, and that's my x. Z plus 2. Okay, so x is z plus 2, y is 2 minus z, and 3 is z. So what this means is if I said x is in, or z is any number, let's just say z is 10. If z is 10. Oh, that's the final answer, I should say, right there, or what they have written over here. But I'm just going to give you some examples. If z was 10, then x would be 12, right? So I could just add 2, and I could do 2 minus 10, and y would be negative 8. And this would be one solution. I could let z be 0. If z was 0, then y would be 2, and z would be 2. X would be 2. And that's another point. All of these points, these three-dimensional points, would be solutions to this problem. So writing that answer that way can be a little bit tricky, but that's what you need to work towards. Your answer should have a bunch of z's in it. All right, here's another example. A young man wins $200,000 and foolishly decides to buy a new car for each of the 7 days of the week, so he has a different car to drive every day. He wants to choose from cars that are priced at $40,000, $30,000, and $25,000. How many cars of each price can he buy with a total of $200,000? So we know he wants to buy 7 cars, right? So there are 3 different types of cars. We can call them ABC or XYZ, whatever you want. So I'm going to call them XYZ. XYZ cars. Okay, how many cars can I buy? Or I want to buy 7. So I want X plus Y plus Z to equal 7 because I want 7 cars. And I know how much they cost. It's $40,000 for X, $30,000 for Y, I'm just doing them in order, and $25,000 for Z, and I have a total of $200,000 that can cost me. So there's another equation. That's all they give me. I only have 2 equations. If I only have 2 equations with 3 variables, this is guaranteed to be not independent. So we're going to go ahead and solve it and see what happens. So here's my 2 equations. Oh, I think this one, oh yeah, sorry, I didn't show you the first page. Let me move that. They just took the 2 equations that we have and they're going to start solving it. So we need, sorry, I'm going back and forth, but this first equation here, we have our 1. We have what we want. We're going to get this to be a 0. How do you get this to be a 0? You multiply equation 1 times negative 40,000 and add it to equation 2. Okay, so that is a lot of big numbers. We're going to use a calculator and do that. So whatever number is here times negative 40,000, that's going to give me 0x. So I got rid of it. It's gone. And these other numbers changed to negatives because I'm multiplying by these really big numbers times negative 40,000 and then adding some 1 something. Next, my next goal is to make this 0. Well, or 1, make it 1. That's pretty easy. We're going to divide all these by negative 10,000, which makes my problem much easier to look at. Now I have small reasonable numbers. I have my 1 here and my 0 and my 1 here. And that's as far as you can go because there's not a third equation, right? So that's all we can do. You basically now just get to let z be whatever you want it to be. Anything. So you don't get to pick anything. You just say z is z. So I know my answer has a z in it. And then you work backwards and you get y. So to solve for y, I would subtract this over here. And I get y equals 8 minus 1.5z. And now that I know that, I can plug it in here. So you have to take that solution and put it in for y. So I have x plus 8 minus 1.5z plus z equals 7. Let's go ahead and subtract 8 from both sides here. X minus 0.5z equals -1. Then we'll add 0.5z to the other side. So -1 plus 0.5z. -1 plus 0.5z is my x, y. Okay. So if no matter what z is for an infinite number of solutions, I can, once I knew what it was, I could figure out x and y. So I know their relationships. So when you give this answer out, you're giving the relationship, not like a specific numerical final answer. And I believe that is oh, there is another example. I thought we were done. That's all right. Oh no, it's just explaining it. If you were to give some examples for this real world problem, obviously you can't have a half of a car. So that's what it's talking about for our final answer. And we also, z can't be 14, right? Because we already know the number of cars that we can buy is only up to 7. So let's make a little chart. I'm going to skip this page real quick, and we're going to make a little chart. If z is 1, 2, 3, 4, 5, 6, or 7, what happens? So let's take a look at our equations. Y is 8 minus 1.5z. So what happens if I do 8 minus 1.5 times 1? Well, that's a decimal. That's not possible. If I put a 2 in here, then that becomes 3. 8 minus 3 is 5. If I put a 3 in here, that's a decimal. That's not going to work. A 4 times 1.5 is 6, so that's 2. If I put a 5 in here, that's a decimal. If I put a 6 in here, then I'm getting 8 minus 9, which is odd, negative, so those aren't even going to work. So far, I've already narrowed it down to this. And now we're going to look at x, and x is -1 plus half z, -1 plus 0.5z. So I don't even need to check these ones that I already crossed off because they're impossible. So let's plug in a 2. Well, that would make that 1 plus 1, which is 0. Let's plug in a 4. That would make this 2 minus 1 is 1. All right. Make sure that your total is 7 because we have to have 7 cars. And then this is the combinations that the guy can buy. If he's going to spend exactly all of his money and buy exactly 7 cars, he can either have 2 of type Z and 5 of type Y, or he can have 4, 2, and 1 of the different types. That is what this page is telling us. So if you want to read that, you're welcome to pause the video and check that out. But that's all we've got for lesson 7.1.